Hi, it's Lucinda Curran here from Eco Health Solutions, and today I wanted to talk to you about relative humidity. I'm just going to share my screen with you so you can see the slides that I prepared. So relative humidity, I always like to start with a definition. So relative humidity is the ratio of current absolute humidity to the highest possible absolute humidity, which depends on the current air temperature. So simply put, we're talking about a way to measure the moisture that's in the air, but it depends on what the temperature is. That's why it's called relative, because it's relative to the actual temperature. A reading of 100% relative humidity means that the air is totally saturated with water vapor and can't hold any more, therefore creating the possibility of rain. However, it doesn't mean that the relative humidity must be at 100% in order for it to rain, but it does mean that where the clouds are formed, it has to be at 100%. The relative humidity near the ground can be much less. So moving on to relative humidity and health, I've taken the next few slides information from this research paper. So it's called Indirect Health Effects of Relative Humidity in Indoor Environments, and it's by Arundel, Sterling, Biggin and Sterling, and it's from 1986. So it's actually an old paper, but it's still very relevant. The reason I've chosen this one is because it talks about the direct and indirect health effects of relative humidity. And the direct health effects would be where you've got a direct consequence of that change in relative humidity, whereas the indirect health effects are where the change in the relative humidity causes some change in the environment, which then impacts on health. So there's that indirect impact on health. So when we start at the low end of the spectrum, the below 30% relative humidity, the direct health effects include eye irritation, possible drying of mucous membranes, including the nose and the throat, and it may be linked to an increased incidence of colds, fevers, sore throats and sneezing. Indirect health effects can include an improved survival rate for rhinoviruses and influenza virus. It may increase the abundance of infective aerosols produced by coughing or exhaling. So that's pathogens that we cough or we breathe out that are then suspended in the air. There's also an increased likelihood of these aerosols remaining suspended in the air, which can have a greater impact on health. Some viruses prefer lower relative humidity, and there can also be increased levels of ozone, and that can cause irritation of the eyes and mucous membranes. In the mid-range, so we're looking at around 40 to 60% relative humidity, the direct health effects can be a reduction in the severity of asthma. Indirect health effects, this humidity range, so 40 to 60%, is more lethal to the airborne non-pathogenic bacteria, and it's suspected that the same applies to pathogenic bacteria. So basically what that means is pathogenic and non-pathogenic. Pathogenic bacteria would be ones that make you sick, and non-pathogenic would just be other bacteria, can be killed off at this level. There's a reduction of virus survival rate, so again that's a lowering of that, and the virtual elimination of house dust mites at around 50% or just below 50% of relative humidity. So once that humidity level drops off, we're dropping down in the levels of bacteria, viruses and house dust mites. The high range of relative humidity, so over 70%, the direct health effects are a reduction in severity of asthma for some people. With high temperatures, it can lead to heat stroke, heat exhaustion or death. Some research has found a link to higher incidence of respiratory conditions in children, particularly boys. Indirect health effects see an increased size of infective aerosols produced by coughing or exhaling, an increased rate of these aerosols settling out of the air, which means they're not in the air anymore and potentially are less problematic, but then they can be passed on through transfer. So like if you're touching them and then touching your mouth or whatever, you can pass them on or get them that way. Some bacteria prefer high levels of relative humidity. Many viruses prefer higher levels. There can be an increased abundance of mites and fungi, which are both allergens. And when we know that there's a significant proportion of our population, so it's at least 10% of the population have allergies, this is quite significant. At above 75% relative humidity, most fungi are really happy. They prefer this level. And there is also an increased release in the formaldehyde from different materials. Excuse the traffic noises outside. So from that research paper, they put together this graph, and the height of each of the bars shows the level of activity. So the higher the bar, the more active, and the narrower it is, then the less active it is. And as you can see, along the bottom, they're looking at relative humidity, and up the side, they're looking at different incidental things in the environment. So bacteria, viruses, fungi, mites, allergic rhinitis and asthma, respiratory infections, chemical interactions, and ozone production. So as you can see, if you look at that bar at the middle, which is looking at the range of 40 to 60% relative humidity, there is pretty much very little activity for all of those. Ozone production being one of the main ones where it's still tapering off down to about 85%, and the chemical interaction can start at as low as about 25%. But other than that, most of them are pretty much near zero at that range. With regards to building biology, we have evaluation guidelines, particularly for sleeping areas, and this is what I've taken the information from on the next couple of slides. So when we look at the indoor climate for relative humidity in percentage, we're looking at these as the ranges, and then I'll show you the next slide where I put this into a table which explains which category they fall under. So when it's between 40 to 60% relative humidity, it's in the no concern category because it's as close to nature as possible. Once it's above 60% or below 40%, there's slight concern. So as a precaution, remediation should be carried out wherever possible. Once we get on those more outer levels, so below 30% and above 70%, it becomes severe concern. So it's not acceptable and remediation should be carried out soon. Then we've got the level of extreme concern where it's below 20% or above 80%. It's not acceptable and immediate and vigorous action is required to remediate it. So with regards to humidity, managing and monitoring it, the following information is from my perspective based on my training with my Advanced Diploma of Building Biology and my 5+ years experience as an environmental health assessor. So with regards to monitoring relative humidity, you can use a very basic hygrometer. The one that I've got shown here is about $20, and this is totally sufficient for your needs. As a professional, obviously we're using much different equipment, but this is suitable. And this will show you temperature and relative humidity. They should cost anywhere from $20. You can get expensive ones that, up to about $70, but this one is a $20 one and it's totally sufficient. So you would use a basic hygrometer to compare indoors to outdoors, and the reason that that's so important is because the moister air will move to areas where the air is less moist. So for instance, if you're having a shower and the bathroom's all steamy, it's probably up around 90 to 100% relative humidity. If you open the window and it's less outside, that moist air will start to leave the building. Likewise, if outdoors is more humid than indoors, then opening up the windows will mean that that moist air comes into your home, which may or may not be something that you want, given that we're trying to keep the levels to between 40 and 60% relative humidity. You can use the hygrometer to compare different rooms and see what's happening with regards to moisture, and also to monitor rooms, especially wet rooms. And I think bathrooms are one really great area, as well as the laundry. When you are using the dryer, for instance, you can see how those levels skyrocket when you use the dryer. So it's a really great way for you to monitor what's going on and make decisions about how you're going to use your space and how you're going to ventilate. In terms of managing relative humidity, there's a few different paths you could take, and obviously they're different depending on your situation, and there'll be different sort of factors to consider with it. Ventilation is always really important, and I'm a very big advocate of ventilation, so opening up doors and windows. Remembering though that moist air travels to areas of the lowest levels of relative humidity. So just bear that in mind. So you might want to check indoors and outdoors before you do that. If you've got issues with moisture in your building, or if you're on that higher end or lower end, you might want to just check what they are so that you can hopefully create some sort of equilibrium. In terms of opening the windows too, it will dilute the air. So it will actually, those levels of the pathogens and viruses and ozone and all of that can actually build up in the indoor air. And by ventilating, we can dilute those levels. You could also look at using humidifiers and dehumidifiers. Now, many families that I visit, they use humidifiers, particularly when the children are unwell. In many cases, it doesn't help. And if anything, it causes more problems because of the risk of, like, that there's more moisture in the air, so there's a greater risk of mold and other problems. Dehumidifiers can be useful, particularly in rental properties, in bathrooms, in the areas that generally are moister. However, I don't want you to think that having a dehumidifier is going to solve a problem. It's going to be a band-aid solution, and it's perfect if you're, as I said before, renting. So there are risks of contamination and the spread of microbes with these units, and proper maintenance is necessary. The heating, ventilation and cooling systems can also be useful, and evaporative cooling is particularly good at reducing relative humidity levels. Again, you can have problems with contamination and the spread of microbes, and maintenance and care of the units is essential. If you're in an area where you have low levels of relative humidity, I know in Melbourne in summer we're sometimes down as low as 8. Plants can be a good option, so indoor plants, because they can increase the levels of relative humidity. However, yet again, care needs to be taken that they do not cause problems. Ways that they can cause problems is their microbiome could be problematic, and oftentimes people overwater plants, the water spills out and then can cause mold and all sorts of problems underneath. So as long as you're being careful with them, plants can be a fantastic option for helping with increasing relative humidity levels. Some final words on relative humidity. So obviously, relative humidity is a parameter for looking at moisture, and mold is a moisture problem. No matter what the issue is that's going on, the source of moisture must always be addressed first and foremost with any mold problem. And if you're struggling to find and control this, then it's recommended that you seek the assistance of a professional, trained and experienced person in this area, such as an environmental health assessor. And if you've got any questions, please get in touch. And there's my email address, lucinda@ecohealthsolutions.com.au. So I hope you found that helpful and interesting, and hopefully that sort of helps create some understanding around the role of relative humidity and health, particularly the indirect effects, which I think is really, really pertinent in understanding the way that it affects our health. I'll catch up with you next time. Bye-bye.